Hi there, I'm Dr. John with Digital Antenna. We're going to have a bit of a talk today about antenna selection and how to get the right antenna for a boat and how to keep you safe in doing so and getting it mounted properly. The first thing we have to take a look at for discussing what antenna we should be using is boat size. And by boat size, I don't mean how huge the boat is, whether it's 10 feet or 500 feet. What we're after is in the boat size is how high can we mount that antenna. If we cannot get the antenna terribly high, like on a center console, and I don't care if that's a 40-foot center console, and we have to mount an antenna here, I have an operator right in this area. He looks like a flower, but this operator with that antenna sitting that close to him and transmitting, we're going to probably do brain damage to him. So this is not something you can do. If you can't get this antenna, even if you use a lower gain antenna, which in this particular instance I would advise, this antenna should still be put up to where the base of the antenna is above the operator's head. Let's talk about gain for just a second before we hit that. This antenna, I said, is low gain, so it's got this kind of a pattern. Okay, big donut, bisected. And we're going to take a regular antenna. This is what you're going to see in the pattern, okay, is that lower gain that's big and fluffy. Okay, and this energy, if we want to do anything with this that we call gain to make this look like we have a stronger transmitter or we want to reach further, all we can do is change the shape of this. We have X amount of power, we can't change that. So when we design this antenna, we make this antenna so that it changes the pattern, and we basically take a lot of this, so we have other energies that are in here. Let's say we had that, and we come over here with this. Well, all of this energy and this energy we can add on, and we end up getting that kind of a pattern. So the energy is no different, it's just we have changed where we're sending it. As gain increases on this, we can end up moving this to a much flatter area, and our donut that we had here, this donut of energy, has been rolled out like a rolling pin, and we made it into a pizza pie. So now we made a pizza shell. If you aren't inside that pizza shell for the other boat or whoever you're going to talk to, you're not going to see this, okay? You won't have that connection. Now, one of the things that happens, we have a smaller boat. A boat that can be rocked around by what the water's doing, everything else as it's moving. And when we take this big fat pattern we had here that's kind of going in all directions, a pattern that we call pretty much an isotropic pattern, and we take this same boat, and I know this is a severe angle, okay, but we have this, and we put our antenna here on the extender. If this is still this big fat thing, that big fat pattern is still pretty much the way it was. Okay, and it continues to function reasonably well. However, if we took this big pattern over here, it's now a pizza pie. This pizza pie is shooting into the water behind the boat. It's going into sky in front of the boat, and it's getting to nobody that's here on this. Well, we had a wave. Okay, our water line is actually here. The boat went up a wave, we lost communication when we got to this point. This would kind of look okay here because we're putting this pattern well above people's heads. We aren't going to hurt the people. What we are going to do is make the small boat have a very hard time communicating if it gets into rough water. Sometimes when you get into rough water is when you want to be able to communicate. Basically, when we draw patterns, we typically draw what the near field of the pattern is going to be. This is just showing that the energy is being dispersed in a much larger area. And you kind of have to follow this out, and this is your communications area when you're out here. Same thing off the back. Okay, you're getting energy moved out in a large area. Just as the higher gain is all around. It's all the way around. It's a pizza pie. Every one of these, this is a donut you stuck over the antenna. Looks just like a donut. This, when we took the donut, we flattened it out, we made it into a pizza pie. It goes all the way around. So would this still work if you had another boat sitting exactly to the side? Yeah, it's still coming over here. Okay, and it didn't change much no matter what the boat did. It's just if there's a boat behind or in front that you were talking to, you're going to miss them because this pattern continues on also. But it continues on like that. Okay, and the same on the back. This is heading off to talk to a Sputnik. Okay, this is going in the water behind it. Yep, the boat over here is working fine. The exact amount of energy is going out. This comes out. Energy is always measured by a meter square. How much energy is coming into that meter? Well, as the energy continues out here, it disperses over a larger and larger area. So the amount in a particular small spot is much larger because the area is larger. The same amount of energy exists here as exists out here, just not the same volume in one little spot. Out here, we're covering a huge circle. In here, we're covering a small circle. When you're talking a large boat that doesn't get all of that wave action bothering it and changing what it's doing, then a high gain antenna is quite good. Okay, especially if you use a high gain antenna like we build, because one of the things we do on our high gain antenna is instead of this just being a flat and coming off at 90 degrees, okay, the way this pattern is, when we do it, we put an electric down tilt on it, and it actually makes this pattern tilted down a bit. This kind of helps because we have a thing out here called the world. And if we're going straight off and we put a boat out in this area and we were coming off straight, this boat here wouldn't be able to hear us, okay, or talk to us. With this down tilt, we get considerably more distance, provided that this antenna itself can be mounted high enough. So when we talk about distance for VHF, for what can you expect for range, it all comes to how high are the antennas and what's the pattern coming off the antenna. Hi, thank you for having listened to any of my little tutorials here. I was trying to keep them pretty basic. We intend to do some more involved tutorials in the near future, and I would be happy to answer any questions that you have. If you can send them in, please send them to support@digitalantenna.com. And again, signing off, this is Dr. John Jones, and my PhD is in electrical engineering and physics. Thank you.